this mistake. When you analyze requirements, they have focused on the ends. You find this, for example, in a user story. I want to do X because I want Y. I want to, in other words, I want the end, the means is the primary statement, and there's a mention of the aims in the user story. Now, Agile is a means for producing the aims or the requirements, okay? So Agile is secondary. Primary is reaching the aims. Follow Einstein's advice. He's a smart guy, okay? So it's the Agile is a secondary tactic for helping us optimize the value and the cost, but it is not necessary for delivering value. You can deliver value in Big Bang waterfall or any other method of just working, and don't worry about the time or the cost or anything. And if you work long enough, you will perhaps reach the value. So Agile can be viewed as a engineering process, a systems engineering process, to deliver the value efficiently. That means at low cost, quickly. Now, you will find some references in square brackets to books. These are 2 books I've written this year. At the back of the slides, you will find exactly which links to get free downloads for these new books. Optima is a book about balancing values and costs. And Evo is really a book about this process here of delivering the value one step at a time. And they're very detailed, and I hope we can, that the purpose of this lecture is to inspire you to maybe look at the books, maybe even do a thesis on some of the subjects of the books. And these are all free, and you're welcome to share them with anybody. So let's see. I would say the Einstein quote, I would call it a profound observation about human beings and the paradox of progress, the confusion. We think we have made progress when we deliver the means, even if we didn't really reach our requirements. That's crazy, but people are doing it all the time. And you need to be taught to see the difference, to analyze the difference, and to deal with the difference, and to come up with the real requirements, that how good we're going to be in the future, the values. By the way, a useful synonym for aims and values could be qualities or ilities. So a simple way of thinking about values is a big subset, an important subset of the values is or all the qualities such as reliability, maintainability, usability, security, safety, and we'll be looking at some of those during the talk. I'd like you to meet an old friend of mine. I actually used to take him to the ballet and dinner in London in 1980s. He was born in 1900. I was always so impressed. Maybe you have a grandfather or grandmother, but he was born in 1900. And he died in 1993 at the ripe old age of 93 years old. By the way, I am right now 83 years old, same age as when I first met Dr. Deming in 1983 in London. And if you don't know who Dr. W. Edwards Deming is, look it up, but he's got a lot of wisdom. And here is his wisdom about requirements engineering. It is important that an aim or requirement never be defined in terms of activity or methods. Einstein called these the means. I would call them technically the strategies or the designs or the architecture. The aim must always relate directly to how life is better for everyone. In other words, how good it's going to be in the future for us. He goes on, warming to my heart, because I love extremely clear requirements. The aim of the system must be clear to everyone in the system. Is this obvious? Well, take any of the extremely popular user stories, for example, and you find they're all unclear always. They're all filled with ambiguous words that nobody knows exactly what it means. I want better security because I feel threatened by hackers. Okay, so that now, what is this better security? How much better is it? And what is the definition of security? So the norm, even the taught norm, the practice norm, is that our requirements are unclear. Many of my books, some I have referred to already, I will refer to more, they go into depth about how to analyze that things are unclear and how to make them clearer. But lack of clarity is everywhere. It is the norm. When you take a job and go to work, they will teach you how to write bad requirements, which will be unclear, and they will threaten your entire project. And you need to be well educated enough to do something about that. Okay? I'm going to take a drink of my coffee before it gets cold. That was good. Now, so repeating, the aim of the system must be clear. Thank you, Dr. Deming. The aim must include plans for the future. What are those plans? Well, one of the plans needs to be the design or the architecture or the means, of course. Maybe the plans for the future include the value it will be delivered at a tolerable level to begin with, good enough, but in some years it will get more and more competitive, better and better. That could also be plans for the future. Anyway, the aim is a value judgment. So he's using exactly the same terminology. He's saying requirement, okay, is an aim, like Einstein, is a value judgment, okay? By the way, he is approximately the same, let's see, when was Einstein was a young man in 1920s when he did his theories, so he must be very, I forget the birth date of Einstein. He died in 54 or 5, I believe, but he must be roughly same age as Deming. We'll have to check that out. So the whole Agile movement, which for 20 years has consumed IT people and become very popular, I think over 1 million people have these false certifications. They take a 2-day course, a false examination, no university education. Of course, they don't know anything, and they become Agile coaches, and that's been a business for a long time. So there's a lovely song here. You can play it here. Peggy Lee sings, "Is That All There Is?" And so the Agile movement has been a complete disappointment that so many people, over a few millions, for such a long time, over 20 years, in spite of my warnings, we'll see some of those towards the end of the lecture, bought into this myth of Agile is great and solves everything. Not you. You will not get trapped by that. But if you did believe in Agile, you must have had bad teachers teaching bad things. I hope I'm not insulting any lecturer who's here today, okay? The important thing is to learn better critical thinking, which I pretend to teach today and in my books, and that your critical thinking will help you understand that the Agile called Scrum, etc., is mainly not going to help your projects succeed. So, a little examination looking at the Agile, the most popular single Agile method, Scrum. I used the artificial intelligence bot, and I said, tell me all about how good Scrum is. Now, here's a list of what we got: flexibility and adaptability, faster time to market, transparency, all very nice sounding things. Now, in teaching critical thinking, I want you to notice one thing: no numbers whatsoever, no experiments, no research, no references to papers with research. Here's a slightly more detailed example of it. So this is very typical. Here is a major method sold to millions of people, used on IT projects all around the world. And when we ask for how good it is, it gives these nice sounding value names. Flexibility is a value. Adaptability is a value. Faster time to market is a value. Improved customer satisfaction is a value. And what does it say? Oh, it embraces change and allows teams. Well, wait a minute. What does it mean, embraces change? What does it mean, allows teams to pivot in response? What are evolving requirements? What kind of market conditions? Nothing is defined. Everything is ambiguous. Everything can mean 1 million different things. In other words, there is no knowledge. There is no credibility in the claim that we have business results from Scrum. There is only the snake oils salesman, buy my snake oil and it will cure all the diseases in the world, blah, 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 blah. So I asked it for some citations for real solid case studies from businesses which give measurable business results. There are 10 of them there, but here's some detail. Again, notice words. Philips, one of my clients, by the way, leverage both Scrum and liberating structures. So that sounds wonderful. Liberating structures. Wouldn't you like to have one of those? To help teams navigate challenges more effectively. What does it mean to navigate challenges? What does it mean more effectively? How much more? When? At what cost? From small to complex. Again, and wherever you look at any of these things, you find words. This is a clear sign that they don't have numbers, they don't have measurements, they don't have good academic or practical research. In other words, they are lying. Probably they are so stupid, they do not even know that they are stupid. That's as stupid as you get, okay? Again, using AI to try to dig out from the entire internet, what does it know? And the answer is more nice words from Spotify and Salesforce and another one of my clients, General Electric and Adobe and Zappos. Words, no data, no proof. You wouldn't get a master's degree for this kind of blah, blah, blah. Okay. So here's Dr. Deming again. Choice of aim is clearly a matter of clarification of values. In other words, which requirements shall we have? Of the many, there are almost infinite possibilities. And we need to reduce this to a tractable or practical level, like maybe 10 top requirements and focus on them. Most, as we shall see, most projects do not deliver their top 10 critical requirements. They deliver none of them and they fail, okay? So if we could even deliver the 10 most important requirements, I call them the critical top 10, then that would be good. We will deliver what we promised for 10 critical things. Anyway, we need it's a matter of clarification of values. And I'm going to teach you that using my Planguage method, planning language, we can clarify the values so that they are completely quantified, measurable, tractable, things like that. And especially the choice between possible options. We're going to look at how to choose, how to compare numerically on multiple dimensions, okay? So I see from my timing, I've used about half of my first 40 minutes that I better move along here if I'm going to get to my friend Musk, so I won't spend. Now, here are some definitions. When you say the word value, it's too easy to think of, financial value, shareholder value, profit value. But when I say values, these are like human values. If you ask the internet to give you a list of human values, you will find over 500 human values like dignity, honesty, trustworthiness. We will see some of these later. So values is quite simply whatever the stakeholders value. And some stakeholders don't value money. Okay. So the other thing is they're not just the values of the users. We have overemphasis on that in the IT. User stories, use cases, right? That's the overemphasis on users. And customers sounds very important, and users and customers are important, but if you have 26 major stakeholders, users and customers are only 2. There are 24 more stakeholders. I will have more to say about stakeholders as we go along, but I'd like to teach that we must get away from these widely taught, widely adopted, narrow and dangerous paradigms of it's all about users and customers. Again, Agile does this in a very bad way. And it's not about one main objective. Many people say, well, the objective of any company is to maximize the profitability for the shareholders. And they're all done. No, no, no. I'm going to teach multi-dimensional thinking, top 10 at least, and maybe 26 objectives, as we shall see for the value objectives. It's not about maximizing anything. It's about balance. It's about enough to make people pretty happy, but not so much that you run out of money and time and can't get it done. Okay, this refers to my Optima book I referred to earlier, which talks about how to balance many values and many costs. And it's certainly not about coding and programming. One of the big faults of Scrum is it really was designed by program coders for program coding, not for systems engineering. And really, you have to go to systems engineering to succeed in anything. You can't just think about the code. Okay. So let's see what values are not. Values are, first, they are derived from many different stakeholders. We'll define stakeholders later, but they hold a stake. They have a requirement. In fact, I'd like to teach this. The source of all requirements are the stakeholders, whatever that means. And this sort of circular definition, those who have requirements are by definition the stakeholders. Stake is another word for requirement idea, actually. Talked about balanced. Here's the reference to the Optima book, which teaches the idea of balance, not maximization. And it's the values are very often the ilities, reliability, maintainability, which is, by the way, reliability, maintainability are related to technical debt, if anybody is dealing with that, and all the other ilities. Okay, now these qualities and the other values, many people refer them as to soft things, soft compared to money or time, and even call them non-functional requirements. Anybody who says non-functional requirements is not very enlightened about requirements. That would mean that they are dysfunctional. They don't function. I'm just joking a little bit. Soft means you cannot quantify them. You cannot measure them. This is not true. All qualities, I'm teaching now, and all values can be quantified That means we can clarify them with numerical precision, and measured reasonably well. That means we can deliver them incrementally and check that they are in fact delivered. So values are quantified. We can use them. That brings us immediately to what we call engineering, as in software engineering, requirements engineering, systems engineering, and we design towards the values so that we get them. Okay, values are about the system level. Here's a simple top-level view of any system called the penta. There's a paper on the penta if you want to go deeper. And I've tried to make something better than what is known as the iron triangle. I'll leave you to look that up or think about it, but you'll find information in the penta paper there. But here we have some notions at the top level of any system. There are some. Here's that design thing I talked about. Here are costs and time and money. Here is functionality, the scope, what the system does. And here are the values. Okay, so here's a little model where we can use it to talk about values and to talk about. By the way, efficiency is the values, how good it is, over the resources, the ratio. In other words, value for money, if you like. That is efficiency, and efficiency is extremely important concept as opposed to maximization. Okay, efficiency is about the balance idea here. Let me introduce you to a Danish guy I know just a little bit, Bent Flyvbjerg. He's actually a professor at Oxford, but also in Denmark. And he wrote a wonderful book I highly recommend, How Big Things Get Done. And we have several slides on him, but here's the headline. He has in Oxford a database of 16,000 projects. And he says 99.5% of them fail either to deliver on time or to deliver within budget or to deliver the benefits, the values they promise. That's another word for values is the benefits, simple, okay? So in other words, some degree of project failure is quite common, and only 0.5% deliver on time, under budget, the values that they promise to deliver. Wow, that is a huge failure rate. Does that mean the universities are teaching people badly so they don't know how to deliver projects on time, under budget, and with the values they should? Let's see, everybody is agile these days. So most of these projects have some agility, I think. And this is another proof that most agility is certainly not solving the problem. And when we look at the book, what is the explanation? We find that the way to break the iron law is that things are failing all the time, he calls it. But it is realistic planning, high quality delivery teams, and incentives or rewards for realistic plans, as opposed to unrealistic plans from politicians to do miracles in a short time on no budget. Okay, so in other words, rigor and mastery and engineering is actually the success formula. Here's more detail on that. Here we have all the projects, the 16,000. Then we have those, half of them were delivered within the budget, probably because for half of the projects, nobody would give them any more money. So they had to end the project, even if it was not complete when the budget was used up. And 8.5% delivered on time. In other words, most projects are very late. And here are the 0.5% that were delivered within budget, on time, and the benefits, the values, the requirements were satisfied. So One of the things is this focus on the values, okay, and professional effort. In other words, real engineers with a good university education, not a 2-day certificate for being a Scrum Master, okay, and quantification and engineering for sure. Engineering is the answer. Okay, only 7 minutes to go through Musk methods. Oh, this is going to be difficult, but I hope to inspire you. By the way, I have a book which will be referenced, but I'll mention it right away, called Musk's Methods. It's a free book. It's a MM, Musk Methods is the code. And I'm going to show you a little bit about Musk. I think Musk is the greatest system developer. He is the greatest systems engineer. He is the greatest requirements engineer. And he must, right now, we have just realized he must be one of the greatest politicians and businessmen of all time. We'll see. He invested, what, $100 million on Trump, and his stock already went up by $50 billion. That's pretty good businessman, I'd say. Okay. Now, what I'm showing you here are just some examples of the engineering accomplishments of Musk. By the way, half of my Tesla is software. Okay. Anyway, this first one is just one little story. Here we have all the auto manufacturers that we have data for how much it costs to maintain per year. And Tesla is the lowest cost maintenance. Maintenance is when it breaks down and you have to pay to get it fixed, or you have to do other things to get it fixed. But so Tesla is the cheapest car to maintain. All other cars, including all the Japanese famous brands who used to be famous for having a good maintenance cost compared to the American ones, are much expensive. You want a really expensive car, the Land Rover will cost you $15,000 a year to maintain. But if you have a Tesla, like I have a Tesla Model 3, I've had this one for, I think, about 3 years now, and it has had no maintenance cost whatsoever, not even actually changing the tires yet, or batteries. So, and this is the experience of the other people in my family that have Teslas. So, okay, so now the reason the maintenance cost is low is that Musk has decided he wants the cars to not break down, and if they do break down, to be extremely cheap to maintain. And this is engineered, this is designed into the car, into the hardware and the software. The key architectural idea is extreme modularization of the hardware and software. Okay, enough of that. Here's yesterday we saw the rocket taking off. It did unfortunately land in the sea, but we know he can catch the rockets with the little pincets. And also here are two landing amazingly in sync. Okay, but the main illustration here are some early rocket motors at SpaceX. Maybe, who knows, maybe based on an early Russian design or something like that. I don't know. I know that that Musk first went to Russia to get early rockets, but they wanted to charge him too much money, so he decided to build his own. And here we have next version, obviously simplification compared to all that complexity. And here we have a third version, and this is probably 2 or 3 years old at least. So he has even simpler. Almost every new motor they make is somehow simplified, and the reason is they believe in simplification, and they give the engineers money and time and experimental leeway to simplify. It's part of their belief system. It doesn't happen by accident. So you want a nice little watch the rockets both land in parallel. There's the link to that. I would call this extreme systems utility when you can do something like that or let it get caught by the pincer. Musk has obviously some very long-range strategies everybody knows about, survival of the human race. That includes all of you. And then he has some sub-strategies like get rid of polluting automobiles so we don't die like they're doing in New Delhi with 60 times higher than maximum pollution. Then he has sub-objectives to design the Tesla as electric, number one, and then to reduce the all the non-sustainable aspects of it, supply of everything. Accelerating sustainable energy is the phrase he uses. He uses advanced agile engineering. He does not use stories and sprints and coding. He uses the same methods that I will talk about in the second half, my Evo methods. Here are, in a nutshell, my Evo method, very similar to a plan, do, study, act cycle to Dr. Deming, just a little bit more detailed, okay? So the message from this slide is Musk has several levels of related aligned objectives. And the lower level technical objectives support the business objectives like for SpaceX and Tesla, which then support the human objectives of getting maybe the human race to other, I hope the moon first and then other planets and then maybe other solar systems. And we're doing on time, 40 minutes. Okay, so finish off Musk quickly, Tom. Another thing that's very interesting about Musk is that he does approximately 20 engineering changes to the car every week. Okay, that means he's doing 1,000 changes per year, very roughly. And these are real product improvements. When they make a change one day, it goes into the next car on the assembly line. No other auto manufacturer does anything like this. They have many years cycle before they make any change whatsoever. So this is extremely agile, extremely, my 40 minutes, extremely evolutionary, as I prefer to call it. But this is an example where I say Musk is the greatest real agilist, but he is at the level of systems engineering. He does another interesting thing. Here are some other automobile manufacturers like Ford and Toyota, and they spend a lot of money on advertising, like for Super Bowl ads. Now, if you think about it, if they advertise and spend a lot of money, does your car get better? No, you just get lured into buying a bad car. What does Musk do? He doesn't advertise or spend money on it, at least. He knows how to advertise in social media, that's for sure. Think X or Twitter. But what he does, he spends all of his money in investing in making the car better. What an interesting idea. Don't spend on advertising like everybody else does. Make the car better. What happens? Actually, he sells a hell of a lot of cars and he reduces the cost of the car, so he has a 20% profit margin. These people are all losing money right now. He still has a very good profit, very good business. This idea of invest in the technical product and hope that the buyers will notice it's a very good product. Same thing with this slide too. It's all the investment Tesla makes in research and development. This is good for people like you who are technical people and want to, I think they have 1,000 applicants for every one job opening at Tesla. May you be so lucky, but boy, will you work hard. Okay. Here's an example from Starlink with the speed of fixing a bug, which made the US military people very jealous, probably takes them 5 years to change a bug in their military systems. Do Musk's projects fail? Well, he is often late, at least late compared to his very optimistic objectives for doing things on time. But he has a history that although he's later than he hoped to be, he is earlier than everybody else by far. And he does accomplish the most incredible things when he does so. So, and there's no doubt about it, it's this engineering work, hard, persistent work that also Flyvbjerg talks about as the key for the 0.5% that succeed in time, money, and benefits or qualities. Okay. Here's another little free booklet for you. If you want to learn how to succeed, you might like to succeed in your studies and the rest of your life. And the book is called Success, Super Secrets and Strategies. Go get it and study it. So there's more about Musk, and I hesitate to use the time on it. I'll leaf through it so you've seen it, but I think I won't. I'll really just wind down. But Musk is giving advice on specification of requirements here, and here's another example of one of the requirements he has valued very highly: the safety of the people in the cars, and he keeps on getting better and better and better. Factory safety for the workers, nice. Also, he does that. Here, out of 50 different, these are all different car manufacturers, but the 3 safest cars rated independently by the National Highway Transportation and Safety Administration of the US has found that the 3 safest cars by far are Model 3, which I have, Model S, which I had before, and Model X, which I almost bought, with the gold wing doors, but I bought this instead. Okay, key architectural idea is modularity and stable interfaces. Very interesting technical subject, but not really one about requirements, one about architectural design. And here are some of the strategies of Musk. There's the rocket he sent up yesterday, the Starship. There is, in a nutshell, Musk's engineering philosophy, and there is what he says about requirements. It's quite fascinating. Assume all the requirements are stupid, even if Musk gives them to you, even if the big boss gives them to you, and challenge them. Fascinating idea. Would anybody dare do that in the working environments you're going to? Okay, everybody's wrong about requirements, no matter how you are. He also notes all designs are wrong too. And there's more here, fascinating study, but we don't have time for it. Here is more detail, me explaining these 5 ideas. Here is Musk's cost improvement ideas, again, worth 1 hour of study just to go through these 10. But I did, how does he control his costs? He has constantly lowering the cost of building the rockets and building the cars, and therefore he has a profit that the other manufacturers do not. Okay, so only 47 minutes. At this point, we're going to take a 10-minute break.
Breaks, and then there will be another link, second part.
Right.
In the second part,
okay.
Because there is 16 minutes. Okay,
I'll go into the other link.
I'll see you in 10 minutes from now.
Right. Okay, I'll go into the other link right away.
Thank you. Bye.